We glance at it constantly while driving, that humble dial or digital display silently keeping tabs on our velocity. It tells us when to slow down, when to speed up, and keeps us safe on the road. We trust it implicitly. But how does your car, without relying on satellites or even external signals, know your exact speed? What invisible conversation happens between your wheels and your dashboard to deliver that precise number? It's a marvel of mechanical ingenuity and modern electronics, a silent guardian meticulously translating the rotation of your wheels into the speed you see, all without GPS. Welcome to the Smart Side, the channel where we unravel the ingenious science and hidden processes behind the everyday. Today we're taking a deep dive into your car's dashboard to reveal the fascinating secrets of how speedometers work, ensuring you always know how fast you're really going. Our journey into speedometer history begins with a direct mechanical link. For decades, the most common type was the cable-driven speedometer, a truly ingenious piece of engineering. Inside your car's transmission, a small gear meshes with a rotating drive shaft. This gear in turn spins a long, flexible cable, much like a speedometer cable on a bicycle. This cable travels all the way from the transmission, through the car's body, and directly into the back of the speedometer unit nestled in your dashboard. Now for the magic inside the speedometer itself, the spinning cable rotates a small, powerful magnet. This spinning magnet creates a swirling, invisible magnetic field. This field then generates tiny electrical currents, called eddy currents, in a small, non-magnetic metal cup that sits just above the magnet. As these eddy currents are generated, they create their own magnetic fields, which then interact with the spinning magnet, causing the cup to try and follow the magnet's rotation. This cup is connected directly to the speedometer needle. A tiny spring resists the cup's movement. So the faster the magnet spins, meaning the faster your wheels turn, the stronger the force on the cup, and the further the needle sweeps across the dial, perfectly indicating your speed. Simple, elegant, and purely mechanical. Wide shot showing entire mechanical speedometer system working in harmony from wheel to needle. While mechanical speedometers were reliable workhorses, modern vehicles have largely moved to the silent, precise world of electronic speedometers. These systems are far more accurate, durable, and provide data for a host of other vehicle systems. Instead of a spinning cable, electronic speedometers rely on wheel speed sensors. These tiny, vigilant eyes are typically located near your car's wheels, often integrated into the anti-lock braking system, ABS. As your wheel spins, a toothed ring or a magnetic encoder rotates past the sensor. Each time a tooth or a magnetic pulse passes, the sensor sends a tiny electrical click or signal to the car's central computer, often called the Engine Control Unit, ECU, or Powertrain Control Module. The ECU acts as the car's central brain and digital detective. It counts these clicks per second from each wheel. Knowing the exact circumference of your tires and factoring in gear ratios, it performs lightning-fast mathematical calculations. Number of clicks per second, multiplied by tire circumference, gives it a precise measurement of how fast that wheel and therefore your car is moving. It's an incredibly accurate digital heartbeat of your speed. For your speedometer to truly be your trustworthy guide, precision and calibration are key. The car's computer needs to know the exact circumference of your tires, as well as the gear ratios within your transmission and differential. These are factory-programmed values. If you ever change your tire size significantly, especially to a non-standard size, it can throw off your speedometer's accuracy. A larger tire, for example, will travel further with each rotation, making your speedometer read lower than your actual speed. For modern electronic speedometers, a mechanic can often reprogram the car's computer to recalibrate for new tire sizes, ensuring pinpoint accuracy. And here's a little secret. Many car manufacturers actually calibrate speedometers to read slightly higher than your true speed, often by about 2 to 3%. So if your speedometer says you're going 62 miles per hour, you might actually only be doing 60. This isn't a flaw, it's a deliberate safety margin, ensuring you're less likely to inadvertently exceed speed limits, and helping manufacturers comply with regulations. The speed data generated by those wheel sensors isn't just for your dashboard display, it's the silent maestro, orchestrating a symphony of other critical systems within your vehicle. This real-time speed information is vital for your anti-lock braking system, ABS, helping prevent your wheels from locking up during hard braking. It's essential for traction control, preventing wheels from spinning on slippery surfaces. Your cruise control relies on it to maintain a steady speed. Even your engine management system uses speed data to optimize fuel injection and gear shifting for efficiency and performance. So, while GPS can tell you your speed, the car's internal, non-GPS-based speedometer systems are crucial for instant, reliable feedback to these safety and performance systems, working tirelessly behind the scenes to keep you and your car running smoothly and safely. So, the next time you glance at your speedometer, remember the ingenious hidden world at work. From the precise dance of magnets and springs in older cars, to the lightning-fast digital pulses of modern sensors, your car is constantly measuring its own journey. It's a testament to meticulous engineering, ensuring that you always have a precise, trustworthy guide to your speed, without ever needing a satellite. Were you surprised by the hidden science behind your car's speedometer? What other automotive secrets or invisible technologies do you want us to unravel on the smart side? Share your thoughts and curious questions in the comments below. If you found this explanation enlightening, smash that like button to support more smart content. Share it with a friend who loves cars, and make sure to subscribe to the Smart Side for more mind-blowing discoveries. Stay smart and keep track of your speed.